Hi, welcome to Spatial Spotlights. This is a Cardo series that dives into different use cases and applications to give you a little bit of a sense of what the platform can do and maybe give you some ideas as well. So, we're going to go ahead and dive in here momentarily with a use case that looks at trying to site new 5G tower locations for a telco company, specifically within Denver. And the first thing that we're going to do, we're going to check out our new Cardo Academy page here. And this is a great resource for anybody that's learning Cardo, Geospatial SQL, anything to do with GIS as well. It has a great section that looks at different interactive maps, some optimizations and ideas, but also for workflows, our no or low code tool to chain together analyses, to scale, to have more flexibility, auditability, the ability to share sorts of complex pipelines as well. And there's a great introduction, some step-by-step tutorials, but also these templates here that you can load in order to get a quick start on different sorts of use cases or applications. So if you know what you want to do in terms of data preparation, maybe you want to filter or join together different geographies, enrich with different sorts of polygons or points, convert to spatial indexes, things like that. All of these are pre-prepared that you can load directly into Cardo and get a jump start on what you want to do. Down at the bottom, there's also some specific industry use cases as well. And the one that we're going to be looking at today is this new tower site selection in Denver. So as we scroll down and see sort of this preview here, we can understand which data warehouses that this is able to run in because different data warehouses have different geospatial capabilities as well, and a quick preview of what this will look like once we get it loaded in. But we can download this. This will actually just download as a SQL file. And when we switch over to our Cardo workspace, we can navigate to our Workflows tab and we can import a workflow just from this local file here. So we'll select our workflow, upload it into our Cardo data warehouse connection. And this will open up in a new tab that will process and load everything from all of those annotations, those colored boxes that have some of the notes that self-document this workflow, as well as the data sources that are connected to it and some of the components too. So for some folks that might not be as familiar with workflows, this is the basic interface that we have. On the right-hand side, we have this gridded area that's our workspace. On the left-hand side, we have our ability to pull in different data sources. We can navigate across our data warehouses to find different tables, and we can just click and drag these into the space as we go. We can also look at different components, and this is the pre-packaged tools that convert things that might be more natural in SQL or some of our stored analytical toolbox functions into these components that are configurable and easily chainable together as well. So you can see that there's all sorts of things from data preparation, spatial generation, importing, exporting, joins, parsers, etc. here. Along the top, we have the ability to pull in these notations. So if we wanted to add a note here, we can just click and drag to create a new one, go through, delete that if we don't want it there anymore. Also importing things from either a file from your desktop or URL, and even generating a workflow description using some AI generative tools here too. But as we dive into the specific workflow that we have in front of us here, the goal here is going to be to try to convert some of this raw data that we have into a dashboard that'll be useful for executives or other decision makers that might want to figure out where they want to site new 5G cell tower locations within the city of Denver. Some of those key source information that we might want to start with, of course, would be coverage. And so this is actually going to be in a quad bin format, which is an equal area size grid that's going to extend over the city here. And that's going to give us a nice way of trying to discretely talk about the signal strength in different areas. And if we expand down here at the bottom, we can see a little data preview as well. That gives us our signal loss statistics, some other information about them, and the quad bin IDs. We're also going to want to look at this buildings data set. Buildings are also a great place that we can site towers, on top of these buildings to provide greater coverage. But if anybody has been in a city with lots of tall towers, you might know that there's this canyon effect that also prevents some signal from getting down below. And so both of these sorts of factors can be very important, and we want to pull these sorts of things in. You'll see we have actually a building height column here that we can pull in, and that'll give us a sense too of the sort of the landscape of this part of Denver. And the last one is going to be existing cell phone towers that we have here. This might be, things that we could add new equipment to, things that could explain some different coverage parameters, things like that as well. So we'll pull this one in here. So as we start to kind of process this, the first thing that we might want to do is find the coverage statistics for each of the quad bin cells within 200 meters of a building. So starting from this building's data set here, we can see that there's a path that connects into this ST buffer component. And here, this is actually just creating a circle that has a distance of 200 meters. This is all set up within this configuration here. And then we'll convert our points into actually a polygon that has the actual area that we want. The other thing that we'll do is convert our quad bins into some center points here. So that way we can actually associate the coverage statistics for the quad bins here with the buildings themselves. The center points help us just narrow down that area of influence so that we don't necessarily double count, and we can more or less understand if the majority of a quad bin is going to be close to a building, or if it's just going to be touching on the exit point here. But together, we can use this point stats and polygon component in order to do that aggregation, that count of, or that aggregation of signal strength per each buffer that we have around here for each of these buildings. So we can configure these components here with the source geometry, the buffer geometry, the column that we want as well in this unique identifier. The other thing that we want to understand is also the distance between the existing towers that we have and each of these buildings. And we have this handy component here, just distance to nearest. We can set a maximum radius here as well, so that if there's no towers within 1,000 meters, we don't necessarily have to sort through the entire data set. We can just say that this is actually just too far for the signal strength that we're looking for, and say that there are no towers nearby here as well. So all of this can be set up and configured within this component. And then the next step that we want to start doing is really starting to think about how we can make this information more accessible to our decision makers. Some of them might be very familiar with the data sets that we're working with and the specific units and information that we have here, but it's often handy to normalize the data on a 0 to 1 scale or as a z-score. And this just allows you to get more information out of that column without necessarily knowing, the full distribution of these values here. You can understand a lot better, is this one of the larger values or one of the smaller values, by just associating that on a 0 to 1 score here too. So here we're taking our building height, we're moving that to a 0 to 1 score, so I can understand on a building by building case basis if this is one of the tallest buildings, so it would be closer to a 1, or one of the shortest buildings, which would be closer to a 0 here. We'll do something similar here for our signal, our average loss, as well as the nearest distance between the towers and the buildings here. But some of these we might want to reorient so that they make a little bit more sense to our decision makers as well. And so here we're actually just inverting, the average loss norm here, so the signal loss here, so that we can better identify where are there strong signal already versus where might there be weak signal that we might want to go in and enhance by putting new information into new cell towers into. We'll drop some of the more unnecessary columns so that we're not bringing over everything as well. And then we'll join together all of this information using this inner join component. And this is really nice. You don't necessarily need to remember all of the syntax. So even if you're more familiar with SQL, sometimes these sorts of components can help speed things up. We'll go through. The next thing that we want to do is also invert some of these other columns, the distance to norm as well. We might want to say that something that's closer to a building is actually something that we might want to prioritize rather than something that's farther. And then the final one that we want to do is actually aggregating these 3 normalized data points into a single sort of score. And this will give a single number between 0 and 1 that will be sort of the representation of what is sort of the best area for an executive to place a new cell phone tower here. So they don't need to know everything about all of the other data sets. They can rely on this score to say that if it's closer to 1, then this is going to be an area that we want to strongly consider as well. So now that we have everything set up here, we're going to want to go through and just hit run up at the top right-hand corner. And this is going to kick off the execution of our workflow. We'll go ahead and see on the top right-hand corner, there's this little ticker with the time that's going up here. And this will let us know that this is actively running. If we wanted to stop this, if we saw that there was an error, we don't want to go through all of it. Maybe this is taking a lot longer than we had anticipated as well. We can go ahead and just stop that. But while this is going, it'll probably take another minute or so to complete. The time that it takes really depends on the volume of data that you're processing, the number of operations or steps that you have going on here, as well as the complexity. And as you see, we can go into our SQL preview tab, and everything that we have set up here within our workflow has been converted actually into raw SQL. Everything is sort of wrapped in temporary tables to make things a little bit more low impact on your own storage quotas and things like that. And you can see that there's some workflow specific things in here. But for the most part, you'd be able to just copy and paste this into another SQL editor, run this against your database, and actually get very similar results or the same results as we have here. And this is very handy in terms of being able to share things. Actually, this is exported into that SQL file that we had imported later, so you can share things between accounts. Or if you're learning SQL, being able to go through and see exactly what the syntax is for some of these different operations or things like that too. So it's also a really great learning tool. But we'll see, actually, this managed to complete in 1 minute and 10 seconds. And now that we have everything that's completed running successfully, we can also see the preview of the different number of rows beneath each component for each one that has run. And this is really handy in terms of that auditability or being able to make sure that you're getting the expected results that you had wanted in terms of the change of rows between each one. We can also go in and view the data preview for each of these components, as well as a quick preview map here that'll just load, not really a styled version of the map, but at least a preview of everything that we have here too, so that we can see that this is what we wanted for building outlines that will have the associated signal strength that has been attached to them. We have the ability here from now, we can go and save this as a table and use this in the future for other maps, combining new analyses, things like that. Or we can go in and create this map right from our shortcut within workflows. And this button opens up into a new builder window. As you can see, this is just sort of loading the data sources that we have here before. If you've worked with Builder before, you'll know on the left-hand side, under the layers panel, there'll be this sources tab that just showed up here as well. We can add sources from our Data Explorer or our SQL query as well. But here we just have this temporary table that the workflow had created that we can visualize directly in Builder and start styling this as well. So as I zoom out, I can see, here are all my polygons that I have as well. And now we were able to start going in and styling this and creating that dashboard type feel that we want for our decision makers to use. So I'll go ahead and rename this layer just so that we have a good base to start with here. So I'll call it the buildings layer. And when I open it up, I'm now able to go and start styling this to better convey the story that I want to tell here. So I'm going to go ahead and turn off the stroke color just because I don't need that level of definition or outline. And I'm going to change the fill color. I open up this more options tab here. And rather than having a single color, we're going to select that the color is going to be based on that final score that we created earlier. We'll see that the palette changed from a single color into a range. We can increase the number of steps here if we wanted to as well. And then just looking for a color scheme that might best fit or match what we're trying to depict here too. So we can go and we'll use this global warming data set or this color palette here so that this bright yellow is going to indicate the areas of best opportunity, the highest score that we had created here. And these darker areas are going to be areas that we're going to try to dissuade our executives, our decision makers from looking at to select different options. And now we can start to see this pattern that's emerged, that we can see that there's great coverage already in the southwest area of this part of the city here. And along the northern side, maybe the southeastern side, are some opportunities that we might want to consider for dropping a new 5G tower here. But one thing that we can also add in here, because we noted that height was going to be an important component, it's part of our final score, but we can also visualize this directly here by turning on these 3D extrusions. So we can go create this as a standard single height, but we can also open this up, say that we want a height that's actually based on that normalized building height that we had created here earlier. We can scale down the height factor as well to make it a little bit more relevant for maybe a building's view as well. And then the last thing that we'll do is just change this from the standard view of the map into our 3D view, which puts us down at an angle. And as we can see now, we have these nice building extrusions that correspond to their height relative to the other buildings that are around them, and are also styled based on that opportunity to drop a new 5G tower. But now that we have our basic visualization or the color style that we want, we're going to want to add some interactivity here as well. So we'll pop over to our widgets panel. We can add a new widget based on each layer here. We can add this first one here that'll just be this formula that'll count the number of buildings that we can see here too. So we'll rename this count of buildings. You can change the formatting or the options here. So we'll add a thousands separator to make it a little bit easier for folks to look at. And then maybe adding in some other workflows or some other widgets rather. A histogram would be great so that we can actually see the distribution of our final score that we're looking at here too. We can change the number of buckets if we want this to be a little bit more precise or more granular. But we can also change the formatting. We'll rename this as well. Final score. And then maybe the last thing that we want to add here is a category widget here that'll help us understand the building types that we're looking at, because a lot of these are going to be residential homes that are not actually going to be accessible for us to put in a new 5G tower as well. So we'll format this with a 1000 separator, just like we did from these other ones. We'll rename this up at the top, building types. And there's other things that we could have added in terms of a description to help people understand this a little bit better. But now we can do things in terms of trying to only look at these commercial buildings that are within our data set. We'll just click on commercial and you'll see that it actually filtered out all of these polygons here as well. And maybe we actually only want to look at ones that have, the highest scores that we have accessible here too. So we're able to really filter down and use some of these widgets in order to make better decisions, not just display a map, but have people interact with it in a really robust way. But we'll clear these out for now as well. Something else that people might want to be doing as they're exploring this map is actually understanding, not just the general distribution or the spread, things like that, but understanding, what are the values for, a specific building. And for that, we can use our interactions. We'll open up the buildings interaction. We can either have a click or a hover as well and start styling this in different ways. We can add all of our fields if we want, but we can also just go through and select ones as we go too. So something that we want to do, put in this final score. And now that when we click on something, it'll pop up and it'll show us actually the individual score for this building, not just sort of on a color scale as general, but the exact score that we can use to compare one to the other. This is a little bit gnarly, having such a long tail of numbers after the decimal point here. So we can go in, we'll rename this label here, final score. And we can change the formatting as well so that we only have 2 decimal points afterwards. And so that'll pop up nice for us too. Finally, we can also go up, add the proper labeling to our legend so that when this pops up here as well, this won't just be the column name, but a nicely formatted legend that we want. And potentially we can change the base map if we wanted to make this a dark layer, really make those colors stand out for our executives to view here. Lastly, I think that we might want to share this, so we could go into our share publishing options here. If folks already have a Carto login, we can actually just use the Carto authentication to make sure that they're properly validated and we know who's accessing this as well. So we'll pop this over to our organization, and now folks can actually go in, log into Carto, and find this within that space there. So with that, we've gone through and loaded a workflow from our Academy page and made it all the way into a dashboard here. It was great to be able to show this off to you. And if you have any questions, feel free to reach out. Happy to continue the conversation. Thanks again for your time.